Today we are going to discuss the concept of potential energy. Did you know the concept of potential energy was the very first concept of energy that was discovered? It was done 2300 years ago by Archimedes. Archimedes invented a lot of machines. And one of the machines that he invented, you have played with. It is called the seesaw. And while playing with the seesaw, he discovered the concept of energy. Let us look at this a little more carefully. So here is the seesaw. And this girl and boy are playing on the seesaw. But generally when you want to play on the seesaw, you expect these two people to be of the same weight, right? If the fulcrum, this point where this is balanced, that is called the fulcrum. Now this fulcrum is right in the middle. Suppose the girl was heavier than the boy, much heavier than the boy. What will happen? The girl will go down and it will get stuck. We don't want that. We want a seesaw where the girl goes down and then the girl goes up and continuously the game can be played. What do you expect? When will that happen? That kind of a seesaw is called a balanced seesaw or a reversible seesaw. Suppose I want a reversible seesaw. In this situation, what do you think should happen? The boy must have the same weight W as this girl. So both the girl and the boy must have the same weight. Then what happens? Then let us say the girl goes down like this. The girl goes down like this. And the boy goes up like this. And what Archimedes asked was, this boy is going up by a height h. Who makes this boy go up by a height h? Who is lifting the boy? Well, obviously the girl going down by this height, and that height you can see is also the same height h. So the girl goes down by the same height as the boy. In fact, it is the loss of this girl's height that makes the boy go up by a height h. So the weight of the boy, W, the height that he gains, h, weight of the girl, W, the height that she loses is h, and Archimedes was able to see that there is WH on both sides. Then he asked a slightly different and a very interesting question. He said, okay, it is all fine to say that a 20 kg boy is lifted up by a 20 kg girl going down. But is it possible for a 20 kg girl to lift up a 40 kg boy? Suppose this was not W but it was 2W. Will this girl be able to lift up this boy? That was the question Archimedes wanted to answer. So now let us look at this situation. So this boy has a weight of 2W, twice that of the girl. So clearly this girl is not going to be able to lift him. But we do have cases where you play with a bigger person on a seesaw. What do? The bigger person moves closer to the fulcrum. Archimedes realized that instead of the boy moving closer to the fulcrum, you can move the fulcrum closer to the boy like that. Well, in that case, they can again start playing. Okay, so this is again a balanced reversible seesaw. And the girl goes down. Okay, so she goes down like that by a height h. The boy goes up. The boy is going up. Clearly you can see that the boy is here. Okay, so the boy goes up. But do you think this is also h? No, right? It looks like it is half. That is something that you need to do experimentally and measure. Archimedes did that and found that the boy goes up half the height of the girl going down. Okay, so the heights moved not equal. The girl goes up down by h and the boy goes up by h by 2. But the weights are also not equal. The girl's weight is W and the boy's weight is 2W. And when you look at the product of the weight into height, the 2 cancels out. You can see that the product of the girl's weight into the height that she is moving is equal to the weight of the boy and the height that he is gaining. So it looks like weight into height moved is the same for both of them, right? Okay, that was fine for 2W and W. What do you think will happen if the boy was weight 3W, right? Then that means we are talking about a boy who's even bigger. So let us look at that situation. So now this boy has a weight of 3W, and if I move this fulcrum from here to there like I was doing earlier, that's not even enough. So you have to move it even closer. So you have to move it somewhere here. So when I move it that much closer, then what happens? Then again they start moving. The girl goes down by a height h and the boy goes up by a much smaller number, and when you calculate it exactly, it turns out that this is h by 3. And again 3w into h by 3. The weight of the boy is 3W. The height he is moving up, h by 3. Who is lifting him up? The girl going down. And the weight that she has is W, and the height she is losing is h. These two are equal. That is, weight into height gained by the boy is equal to weight into height lost by the girl. Now what Archimedes thought about here, looked at this and said, there is a deep idea here. That weight into height is not really lost. The girl is not losing her weight into height. Yes, it looks like right now she has lost it, but the boy has gained the weight into height. Different weight, different height, but the product, weight into height, is exactly the same. So what the girl lost, not as height, the girl lost a height h, the boy only gained a height h by 3. But don't look at height, look at the product weight into height. The girl lost w into h, the boy gained 3w into h by 3, exactly the same thing. And now the next step, right, is when the boy goes down, the girl will go up. The boy will lose 3w into h by 3, the girl will gain w into h. So the idea that w into h, weight into height, is not really lost. Okay, it is getting only transferred, was something that struck Archimedes. Now, obviously, if such an important quantity that is not getting lost, it must have a name. So he gave it a name, he called it potential energy. Let us now look at what Archimedes deduced from his experiments. Let us now quickly see what Archimedes realized from his experiments. So very first thing that he realized was weight into height is an important quantity, because weight into height is not lost, it is only transferred. And in physics, whenever something is important, we give it a name. The name Archimedes came up with was the idea of energy. Today, of course, we call it potential energy, PE for short. Okay, so weight into height is the potential energy. Okay, it is a very, very important concept because of the fact that when one object loses it, another object gains it. It is not lost permanently. So for example, in the seesaw example, right, one object loses height. So the weight of the first object into the height that it lost is equal to the weight of the second object into the height that it has gained. So that means this weight into height that was lost by the first object is transferred to the second object, which gains weight into height. Okay, so far we are looking at potential energy lost and potential energy gained. But we can then go on to the next idea, which is to talk about the potential energy itself without talking about lost and gain. And that is also weight into height. But when an object is kept at a height like this, for example, if I take this ball and keep it at some height from the ground, then I can say it has a potential energy weight into height. So weight into height, we can think of it as potential energy of this weight, this object, when it is kept at a height h. So when it's kept at a height h, it has a potential energy weight into height. When it goes down, obviously it has lost it, right? Because the height has come down, so it has lost it. But when it loses, it's not lost permanently. It is given to somebody else, that somebody else gains it. So the key concept that we have learned now is weight into height is the potential energy of an object.